Oh, it is not showing anything. Ah, yeah, now came. Okay.
Sir, audible? Am I audible?
Ah, yeah, audible.
Sir, this session, sir, can we solve some problems on the question concepts you gave the last class?
Okay. Now I am giving you questions. Suppose CH3, CH2, and OH is there, right? And if you oxidized with different oxidizing agent, I am giving you. First one, they have given PCC, pyridinium chlorochromate. Second one is KMNO4. Third one is K2Cr2O7. Next one, CrO3. Next one, concentrated H2SO4 at 443 Kelvin. Next.
Sir, in this one, sir, I have just read. So, sir, can I refer to the notebook, sir, if I am finding anyone difficult?
Okay. 413 Kelvin. Copper powder at 5 is not 573 Kelvin. Alcohol is not having much problem. Very lesser number of problem are there. The same one.
Sir, first one will form CH3CHO. First one will form CHO.
Correct.
Sir, CrO3, this will form, CrO3 will also form CH3CHO only.
CrO3, yes.
CrO3 also from CH3CHO. Sir, in case of concentrated H2SO4, only water will go away. So, sir, it will form. No. In case of concentrated H2SO4, water will go away. And
443 Kelvin, it will give alkene plus water.
H2SO4 and H2O.
And here is it diethyl ether. Just in the morning class, you wrote by yourself.
Yes, sir. Second one I remember the diethyl ether. First one I just I was confused whether it will be CH3CH3 or CH2 double CH2.
No. CH2, CH3. Copper powder, if you are taking the 1 degree alcohol, na, so this will give aldehyde CH3, CHO plus H2. If it is 2 degree alcohol, it will give ketone. Here they are the strong oxidizing agent. A strong oxidizing agent. This is also a strong oxidizing agent. So they will give directly to acid CH3COOH. Okay.
Sir, is there any short method that how to remember these things? Because so many things are there, sir, I'm finding difficult to memorize.
That is what, na? That is, you can write the precise notes. I will let you know, na, all the reaction together, na, you make the short notes in which the, like what we are making now, total reaction of the alcohol at single page.
So that will be very helpful, sir, if I get that. But sir, where it is available, sir?
That I will, that we have to made by ourselves. If we are making from by ourselves, that will be very effective. You can read all the reactions and line by line you write. Like if I will write PCl5, right? So CH3, CH2, Cl, it will be there. Okay, somewhere we wrote now PCl3. What is there? Same CH3, CH2, Cl. This all the reaction we study now. SOCl2, the same
Sir,
will be.
suppose I make this type of thing,
एक
but sir,
मिनट सर, थोड़ा सा मैं इंटरवेन करूं, आप
Okay, tell me,
परमिशन देंगे तो।
tell me,
सर मैं कल मैं आंगुल गया था, एक्चुअली जहाँ पे बुक्स वगैरह मिलते हैं वो मोटा मोटी ये हम लोग जहाँ पे रहते हैं वहां से 20 किलोमीटर दूर है।
हाँ
तो
हाँ
कल मैं गया था सर, वो आरिहंत वाला बुक तो हमको मिला नहीं।
हाँ हाँ।
तो दे टोल्ड मी और भी 7 दिन लगेगा वो आरिहंत वाला बुक लाने के लिए, वो जो आपका
हाँ।
10 years क्वेश्चन वाला।
ओके ओके ओके
तो आपने बोला ना आरिहंत का ही, तो बाकी मिल रहा था बट मैं लिया नहीं, तो आरिहंत वाला और 7 days में मिलेगा सर।
ओके सर, नो प्रॉब्लम सर।
ठीक ठीक।
वैसे अदर भी एक आध तो रहेगा, एक दो और भी रहेगा तो कोई प्रॉब्लम नहीं है सर, क्योंकि
नहीं मैं
उसमें
सर वहाँ पे
सेम ही।
ये वाला मिल रहा था, एमटीजी वाला मिल रहा था बट मैंने लिया नहीं, 10 years वाला।
अच्छा, एमटीजी मैंने उतना देखा नहीं हूँ सर, तो मुझे बहुत ज्यादा आइडिया नहीं है।
तो ठीक है
अरिहंत
सर,
वाला।
ये वाला आर्यन वाला आएगा, 7 दिन में आ जाएगा बोला।
ओके ओके सर, नो प्रॉब्लम सर। तब तक इधर मैं फिनिश करता हूँ, कोशिश करता हूँ
ठीक
कुछ
सर,
ज्यादा
ठीक
पढ़ने।
ठीक सर।
ओके। So what you need to do, Sanoy, that is you need to write the reactions in the short form. All the reaction we study now, the same way you have. हाँ,
sir,
CH.
provided I write this type of things, so sir, so if I write and send it to sir, can you check it once, sir? Whether
That I will check. You can also check now. All the reactions are there from the book. You are going to make from the book only.
no, sir, better if you check it, sir. I do not have that much trust on myself.
हाँ, okay, no problem. That I will do.
बिकॉज ये फाइनल वाला बन रहा है ना सर, इसमें कोई गलती रहेगा तो पूरा साल वो रह जाएगा, सो दैट
That
विल
is
कॉज लॉट ऑफ प्रॉब्लम।
that is okay. That is why na. Here, okay, CH3, CH2ONA. Is it there? What else is there? Esterification is there. Esterification. If you are treating with CH3, COOH. So this will give what? CH3, COO, C2H5. These are there. Maximum reactions are covered like this. Okay. And if you are going for the phenol, morning we study na method of
Sir,
preparation of phenol.
once again, last page, sir, last page once again, please. Just for
Yeah,
1 minute.
yeah.
I'll get that noted by
No,
then.
no, 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 no problem, no problem. Like this, if you are making na, so it will become very convenient to practice also. If it is in the form of flow chart, it will take 5 minutes hardly to practice all the reactions. And chemistry is all about na, reactions are all about how many times you are practicing a day. In a day, you can practice 1 time, 2 times. During on the Sunday, on the holiday time, you can practice 2 times. All the reaction can be practiced once in a day. That is possible because it will take hardly 4 5 chapter are there na, 4 5 page. 4 5 page we can easily do, and reaction do not require too much time to write. That
So
is what.
steam ball is nice.
Hmm.
Yeah.
I did not write the side product in all cases. Side product
No, sir.
already you know.
Sir, if they are giving in the exams, sir, mentioning side product is mandatory, or we can write only the main product also?
Some reaction is mandatory to mention. Okay, whatever the reaction in NCRT, if the side product is mentioned, that you need to mention in the exam also. If the side product is not given in NCRT, if you are not mentioning, not a problem.
Okay.
Huh.
Okay.
Otherwise, you have to mention. Now, in the morning, we study now method of preparation of phenol.
Yes,
Methods
sir.
of preparation of phenol.
Sir, um, sir, one is
Cumene.
cumin, there aniline, chlorobenzene, benzene, sulfonic acid.
Yeah. That is okay. See,
That's
we are.
Sir, I referred to my copy only. Sir, this flowchart is already with me. So, sir, I don't need it once again. You can do some other one.
No, I am just giving you the very short description how you can. Okay. So how we were preparing, said it cumene we were taking. Now cumene structure it was like that. It was that is CH. This side it was CH3. Outside this is CH3. Okay. This is also called isopropyl benzene. You treat with the oxygen. So these both the oxygen where it is going to add now here this position is they are going to add. Okay. So you see how the reaction is. Here it is O, here is O, this is H. CH3, this is CH3. And now if you heat this one, na, So what will happen? This total upper portion will be going to out. This portion is going to be out. Getting my point? So what will be
Yes.
there? Side product will be what? Minus CH3 COOH. This will be their side product. Our remaining will be what? This is going to be phenol. Now let us see if you are taking aniline. Uh, aniline, I told you na, that is you can go diazotization process. Diazotization means NaNO2 plus HCl. It is 0 to 5 degrees C. Diazonium, this is the what it will give? Diazonium chloride. This is N2Cl. And you are going to warm it. If you are H2O, but you have to take the warm water. So it will give the phenol. Getting? Another, we are having the chlorobenzene. Chlorobenzene, because of presence of partial double bond character, it is difficult to react. So you are treating NaOH with NaOH, there is no problem. But what the problem is, you have to take 623 Kelvin and 300 atm. So it will give the salt, diazonium, this one, sodium phenoxide, this one. Then you hydrolyze it or acidified it. So it will give the phenol. One more is there, benzene sulfonic acid. So what we are taking benzene, then we are taking oleum, or that is oleum is nothing but concentrated H2SO4. Okay. So what it will give? This will give the benzene sulfonic acid, that is SO3H. You take the two condition required. First one, you take NaOH. This is actually two-step process. So if you are treating with NaOH, the same reaction will be going to repeat this one. And then you need to acidify this one. So it will give phenol. So this was the method of preparation that already we have covered this one. Yes, Jan.
Yes, sir.
Already
Sir,
we have discussed.
one second, sir. This is not completed. Not completed.
See, chemistry is all about how much interest you are taking. If you are started no to have the interest in the subject, now it become very easy. Reaction automatically become easy, and it will become easy for you. There is not a problem. I don't have doubt, because once we are starting the doing problem, na, then it will become easy.
Hmm.
So we will do the problem. Let us finish first the syllabus.
Sir, done.
Now in the morning we have done
Sir, after we finish this one, sir, we can revise these things and the extra chapters and 11 chapters also.
11 chapter. Which chapter is 11?
Sir, all the 11th class 11 chapters.
If you do like that, na, after this chapter you revise 11. I don't
Not
have time
after
for.
this. Sir, not after this, sir. After we finish the syllabus.
That time that we will see. That we will see. Okay, that is not a problem. But firstly, you finish this one, 12th chapter. Okay, you write the board exam. We are having time. We'll see that one situation. In the time, if we are having time, what we will do? That we will practice only now. Let us see. Chemical properties, I told you, chemical properties of phenol. Chemical properties of phenol. So if you see chemical properties of phenol, there is only three possibilities are there. What possibilities are there? See, in the phenol, if you see what type of bonds are there, O, this is there. Okay, these are there. So it can be due to what is there? OH bond, OH, COH bond. Here is what is there, partial double bond. This is what is there, partial double bond. This is what partial double bond. And since partial double bond, so it is not having no reaction. It is not giving any reaction. Other possibilities is there due to what is there, due to O-H bond. Already we have done due to OS bond. What is with the sodium metal, with the NaOH, and esterification. These three reaction in the morning time I already finished. Last possibilities is there due to benzene ring. Due to benzene ring, there are 6 reactions are there due to benzene ring. What are the 6 reactions? We are doing according to the priority order. Which one is most important? Here is, if I will write this one, Riemann-Tiemann reaction. Riemann-Tiemann, Tiemann. Riemann-Tiemann reaction. Okay, this is Riemann-Tiemann reaction. Second one is there. If we talk about the priority order, this is the oxidation of phenol. Third one, if you can see the third one, reaction with zinc dust. Yeah, reduction with zinc dust. Reaction with zinc dust. This is there. If you go for the fourth one, this is the Kolbe reaction. Kolbe's reaction. Fifth one, nitration. Nitration. Sixth one, bromination. These many reactions are there, not more. Bromination. Within 5 minutes, you can revise these things. Even not, it will not take 5 minutes even. Done.
Done.
So what we have to do, already we have finished this one portion now. Which portion? This we finish, this we finish, this we finish. What we left out, this portion we left. So this portion I am trying to finish right now. Okay, this one. Okay, see nitration, wherever you are writing nitration now, you write two heading. One is the dilute HNO3 and another is concentrated HNO3. Here, and in the bromination also two is there. One is the Br2 in CS2, and another is the Br2 water. So they are the different reactions are there. If you all together, if you add, it will going to be the 10 reactions. Around 10 reaction with the conditions. So can we start the reaction? So first one we are going Reimer, Reimer. Actually, in the book it is given the letter portion, but I am doing the first this one. Why? Because it is most important reaction of this chapter, Reimer-Tiemann reaction. What this reaction is all about? Okay, when phenol is treated with, two reagent we take, phenol is treated with CHCl3 chloroform. This is what is chloroform, and aqueous NaOH. Both. When phenol is treated with CHCl3 and NaOH, then it gives what it is going to give. Then it gives intermediate. Which on reaction with NaOH, it is going to give the another intermediate. It is again going to give the another intermediate. Another intermediate. I will show you how the reaction it is going to give another intermediate, which on acidification gives salcyl important compound, SALICYL aldehyde. This is the salcyl. This reaction I'm explaining in the two form. One according to NCERT and one according for the understanding. NCERT is simply based on memorize. This NCERT, they do not give the detail because it is there in the graduation also. If you talk about NCERT, this is memory based. But I will explain you both the form you need to know. So NCERT based, what there is there, this is the phenol. This is what? Phenol. Phenol, you are Riemann-Tiemann reagent is, this is the Riemann-Tiemann reagent. When phenol is treated with chloroform and sodium hydroxide, it directly gives the salicylaldehyde. This is the what simple you can write in the board exam. When phenol is treated with chloroform and aqueous NaOH, it gives the salicylaldehyde. Okay, the reaction is called what? A Riemann-Tiemann reaction. 1 marks question. This is the 1 marks equation. So simple, you write the reagent CHCl3 chloroform CHCl3, and then we have to use that is NaOH. So let us write CHCl3 plus it is NaOH. This NaOH is aqueous, so it is going to give the intermediate. Firstly, this is the base, and phenol is acidic, so it will give salt. This is salt. And CHCl3 there, here is one hydrogen will go, it will give CHCl2. Another you treat with the NaOH. Okay, so what you are going to give this one CHCl2 will convert into the aldehyde group. But I told you this is a memory base. And you what you need to do this one, if you hydrolyze with HCl is the form intermediate, so it will give the required product. This is there. Here is it is sorry, yeah, this is again and again I am writing the same. This is the ONA, sodium phenoxide, ONA, which we are acidifying. So what is there? This is the OH, and this is as it is CHO. But this reaction is memory based reaction. Now I am explaining it to you how we can explain. Suppose what is there for understanding. Now I will share you the PDF if you are lacking the time. So here is O, this is what is the H, and here is what we are treating NaOH. Morning time I told you phenol is acidic in nature. Why it is acidic in nature? Because it gives the neutralization reaction, acid base reaction. So this H and this OH is out. So it is going to be minus H2O, right? Then what will give? This will going to give the phenoxide, ONA. This is reactive in nature. Now every carbon is having hydrogen. This is hydrogen. Now chloroform structure you must be knowing. What we are having the CHCl3. Here suppose we are having Cl. Here is Cl. This is the Cl, and here is H. What we are going to do? We are removing this HCl. So you see what we are going to get here if you are removing this one. So which carbon? This carbon is going to attack. Which carbon? If I will say this carbon is going to attach at this position. So let us write another one. ONA will be as it is, ONA, right? Now HCl is out, minus HCl. What is left? This CH is going to be left, this one. So I am attacking here CH. How two more Cl are there? This is Cl and Cl. So this intermediate, we wrote like that. But how it is happening, that you should know. Now what we are going to do, you are treating with the 2 NaOH. You are taking 2 NaOH. So if you take the 2 NaOH, this one will be out, minus 2 NaCl. It is very systematic reaction. Very systematic one. Slowly you will get to know. Now this will, what it is going to give, here you see, keep on watching this one. ONA. Here it is, what is there? This is the CH. Here is OH. Here is again OH. This whatever the left OH are there that got attached. Now what is happening? This water molecule will be out. Water molecule. So what it is going to give now? This will another intermediate it is going to give. ONA as it is. Now it become left with CH. This is the hydrogen, na? This is CH and this oxygen CHO. So another intermediate this will come, but they did not give in the book. Some portion they are not explaining, like they left this into this portion in the NCRT. They left this portion. Now what we can do? You acidified with H plus. Yeah, actually, which H plus? This HCl is coming out. Now that H plus only use. You didn't. Here what it will give? That is here it will come OH. Here is CHO plus NaCl is out. You need not to write NaCl because you are using only H plus. So this reaction is little bit tough. Can I explain once more or you will be able to?
Okay, sir. I think it needs to be memorized.
See, in the exam you need to write the upper one, memory based. But sometimes it get very difficult to know how it's happened. So to know the how it's happened, this is the downward. This is what is called benzyl chloride. Can I reach? Okay. Second reaction, you see the oxidation. Very simple reaction, oxidation reaction. Very, very simple. Okay. When they are saying when phenol is oxidized with chromic acid. This is chromic acid. When phenol is oxidized with chromic acid or sodium dichromate, anything you can do. Sodium dichromate in presence of H2SO4. In presence of H2SO4, it gives benzoquinone. One thing you keep in mind, what the note I am writing on the note. Oxidizing agent supplies something. What they supply? Oxidizing agent, what they supply? Oxidizing agent supply what? Nascent oxygen. Reactive oxygen. Nascent oxygen means what? The reactive oxygen. Okay. Nascent oxygen. We mention in the square bracket. Here you see, this we are having phenol. Okay. Downside we are having H. Now what we are using? Two nascent oxygen. Where you are giving Na2Cr2O7 and H2SO4 also we are taking together. Na2Cr2O7, comma H2SO4. 20 minutes. So what will happen, Sanoy? Here you see this hydrogen, one oxygen, one hydrogen. They are going to be out. Okay. In the ring, better you need to write this one, alternate single and double bond. Now, what you can see, if the water is removed, H2O is removed. So what is left? Here the oxygen left, this one. And two oxygen we have taken, one more oxygen is there. So this will be the bond. This is what is called benzoquinone. Statement, generally whatever we are writing this statement in the board exam, generally they ask the equation. Statement not required. If you know the equation, you can write the what will call. If you know the reaction, you can write the statement also.
Okay.
So this is the two reaction we studied. Okay. Next one we are going for the reaction with zinc dust. Yeah, reduction with zinc dust. Reduction with zinc dust. Okay. This one very simple reaction. So no need to write the statement. It gives what? Benzene. It gives benzene. Now you see here. Here what is there? OH. You are treating with the zinc. So if you treat with the zinc, what will happen? This oxygen, this zinc will be out. So what it will give? This will give going to give the benzene plus what is ZNO. So this is very simple reaction. Once it is done, let me know. Done.
Yes.
Next, we are studying Kolbe reaction. Kolbe's reaction. See, a statement you can write also when phenol is treated with NaOH, it gives phenoxide. It gives phenoxide. It gives phenoxide. Which on reaction with CO2 give which on reaction with CO2 gives what it is going to give? Salicylic acid. SALICYLIC. Salicylic acid. Salicylic acid. This is L. Salicylic acid. This reaction is so simple, not to worried here. This is the phenol OH. First of all, we have to treat with the NaOH. So all the reaction react with the NaOH, most of the reaction. So they give the sodium phenoxide, reactive sodium phenoxide, ONA. Now they are talking about you treat with the CO2, first condition, and second one acidified, H plus, acidified because phenoxide is there now, Na is there, so we have to remove. So simple, this is going to give one. On acidification, ONA become OH and C double O, and here is hydrogen already there. So what will be there? C double O and H. This is what is salicylic acid. This is. Should I explain again?
No, sir. I understand.
IPAC name is 2-hydroxybenzoic acid.
Done.
Now next one we are going for bromination. Bromination. Bromination you need to memorize. See, case 1 is there. Case 1. Bromine water. If you take bromine water, water is polar, so more it will ionize, na? It will more ionize. Bromine will ionize in water more. So bromine water gives, what will it give? Gives 2,4,6 tribromophenol. Tribromophenol. This will give tribromophenol. And this is the white precipitate, white PPT, tribromophenol. And case 2, if you are writing case 2, bromine in CS2, carbon disulfide, carbon disulfide. So this is the CS2 you are taking, carbon disulfide, right? CS2. So it is non-polar solvent. CS2 is non-polar solvent. You can understand carbon here, sulfur, double bond. So here dipole this side, dipole this side. Dipole is vector quantity. So they will mu is equal to, they will cancel out each other at 180 degree. So in the non-polar solvent, they are not going to ionize. So it will give para-bromophenol. It is going to give para-bromophenol. Reason I am actually para-bromophenol. OH is there. They are talking Br2 in water. Okay, that is also called bromine water. Bromine water, simple. So tribromophenol it will give. It will OH. Here is going to be Br. This is Br. Here is again going to be Br. Okay, this is there. Now, if you are taking Br2 in CS2, Br2 in CS2, so this will be like that. OH downside Br. This is the 2,4,6 tribromophenol. And this is the 4-bromophenol. Why it is tribromophenol? Because it is in the polar solvent. Bromine will be more produced. So it will give tribromophenol. Done.
No, sir, writing.
This is only NCERT based. Nothing is the problem here. Very easy only.
First one, bromine water. Second one, gases. Sir, CH2 is known as carbon disulfide. no?
Carbon disulfide, yes.
Done.
Done. Next one, nitration. This is the last reaction of phenol. Okay. Nitration of phenol. Okay, this is there. How can we study nitration of phenol? It is two cases are also there. Case 1. With dilute HNO3. Okay. It gives ortho It gives orthonitrophenol as major product. It gives orthonitrophenol as major product. As it form intramolecular H bonding, while paranitrophenol, p-nitrophenol as minor product. So now see, this is the OH is there, where we are treating with the dilute HNO3. So it will give the OH. Here is the NO2. This is the major. Generally, major is the para, but in this case, this is the ortho is major. Ab region they are talking about, region. This is also the region, this is the volatile. They ask that is, and this is not, because it can exist alone, and this is non-volatile. The compound which exists alone, that is volatile. See, region I am writing. So if you write this one, OH and double bond O, coordinate bond O. So what it is going to form? This is the hydrogen bonding. This. So this is, since it is forming a hydrogen bond, so that is what is stable. The compound, it becomes stable. Stable, not stable. This is major, not stable. Sorry. Stable and major is different. Major. Case 2. With concentrated HNO3. More nitro group it will give na concentrated HNO3. It gives 2,4,6 trinitrophenol. This came once already, we did this one, also known as 2,4,6 trinitrophenol, known as picric acid. We study this one haloarin topic.
Yes, sir. I remember the name.
So this is the what is OH. You take the concentrated HNO3. So this will give this OH. Here is, this is NO2, and NO2. Picric acid.
Done, sir.
So this is the reaction of phenol over. Now the one more class required for the that one, that is what is called ethers. Okay, aromatic ethers and aliphatic ether. For night time it will be over if you join by the 11 o'clock. If I will be available, I will call you myself at 10. So we'll try to finish. This one also will finish.
Chapter will be finished, sir, if you have time.
Today we will finish na. If I will be available by 10, so 11 100% we will join. But in case I am available, I will inform you. You can also text message by 10. Important. Some commercially important alcohol. Okay. Two commercially important alcohols are there. First one is the methanol. Methanol. And second one is ethanol. Ethanol. It is called spirit. It is called spirit. And it is called, no, ethanol, it is called the simple we use, that is alcohol. It is used for the burning purposes. Okay. And alcohol used where we are used in beverage. Okay. Used in beverage. Means cold drinks. In the drinks, matlab. In the drinking purpose we use. Now, what they are talking about here, how we prepare this one. Carbon monoxide, very harmful. And then H2 gas we are passing. What we are doing? Here
Sir, not audible.
hello.
Sir, audible.
Wi-Fi gone, na? So I could not recognize what happened. This was there. So see, 200 to 300 atm is there. If you reduce the pressure and temperature, so it will go reverse, and it become give the poisonous carbon monoxide. So person immediately they die. If you are taking the carbon monoxide, some people took sanitizer and some other things during the COVID time.
COVID time.
They die immediately. So this is there. This is poisonous in nature.
Sir, sanitizer means, sir, if you take that in your system like directly, then it will happen, sir. Otherwise, if you mix it in water or something, then it will get diluted. So, sir, it will not have that much harmful effect.
But they said that the chloroform kill the sometime damage the cell wall of the soft tissue. I don't know. That is
But
why
sir,
they.
it is told only, the methanol is made only unsuitable for drinking. It is they are telling only.
Methanol is how you are using spirit. Then we use as a solvent for paint.
I'm getting.
Varnishes, etc. Right. Now you see this one, how we prepare this one. So if you take the sugar, na, C12, H22, 11, by the fermentation process, we prepare this one. Invertage enzyme, invertage. So what it will give? Firstly, it will give glucose and fructose. C6H12O6. This is glucose. Again, it will give C6H12O6. This is fructose. Fructose, right? Now, the same one you see again, C6H12O6, and you take Zymase enzyme, Zymase. So it will give 2C2H5OH plus 2CO2 molecule. Sometimes they did not ask till now this one, but they asked the denatured alcohol.
So denatured alcohol only. I was talking about that one.
Hmm. Hmm.
C12H12.
So this one asks, a question is there, what is denatured alcohol?
Sir, you can send me this PDF, sir, after you are done, right?
Yeah, 100% I will say. Denatured alcohol. The alcohol which is
Made unsuitable for drinking by adding the dye.
which is not fit for drinking. Not fit for drinking. Drinking. Or poisonous alcohol. Poisonous alcohol is denatured. How you can make the denatured alcohol? If you
Adding
add
the
if you add the copper sulfate, na, it will become the denatured. If you are having alcohol, you add the CuSO4 plus pyridine. Pyridine. It will be the denatured alcohol.
Sir, pyridine has which function, sir?
They help in dissolving this one. Pyridine as a solvent they use. They said that is commercial alcohol is made unfit for drinking by mixing it some copper sulfate to give it color and pyridine. That is what denatured alcohol. So this is there. Now you put the heading that is study of ether. Today we will finish study of ethers. Study of ethers. Okay. Night time you connect. Done.